Hello and welcome to my first video. Today I'm going to talk about manual failover with multiple internet service providers. First of all, first question is what is a failover? So if these devices are devices with a wireless interfaces are connected to a central device here, let's say a home router, and this home router has access to my main ISP. During a normal operation, the entire traffic will exit out of this interface going to ISP1. But this router, or they may be different devices here as well, they are also prepared for one or in my case two backup internets. So if the first one fails for some reason, we can switch over to number two or to number three if needed. Now, maybe it's a little rare situation that a home user will have two backup internet providers, and I'll explain my actually my story in the next minutes why I have two backups. But you can copy the configuration part of the ideas here and apply it to your personal needs. So, second important question is why manual? And here I have to say that we can have actually automatic and manual failover. Automatic means that if the device here understands somehow that ISP1 is down, it can switch over automatically to ISP2, for example, or ISP3. And automatic failover is actually very cool, and it has one very big advantage: less downtime. And the connected devices maybe will not even notice that something is going on the network. But there are also some important situations and considerations why manual can be preferred. These are my reasons here. First of all, I have better control. I have much better control when I can manually select ISP2 or ISP3 or back to ISP1. So driving manual transmission car is you have much better control compared to driving automatic transmission car. It may require more skills to learn to drive it, but you are in a better control. Also, uh, I am immediately aware that ISP1 is down when it doesn't switch over to ISP2 automatically because I'm immediately affected, of course, when I'm using the internet at this moment. So I can call my ISP and say, hey, uh, come fix your network. And until they do it, actually, I can go and use um, one of the other providers. Second point here is can be cheaper, and what does this mean? In my particular situation, ISP2 is a mobile data router, and my contract is for a megabyte, so I'm paying for megabyte, and the more I use it, the more I pay it. So I prefer to use it really only for emergency or for backup situations. And point number three is another interesting situation, which can be conflicting with point number two, because in point number three here, I'm discussing a situation where you want to use the three simultaneously with some kind of not automatic load balancing, no, but manual load sharing. So for example, this device uses ISP1, then this device uses ISP2, and as you can imagine, the other device can use ISP3. And this is accomplished based on different wireless networks, different SSIDs, and each SSID is can be mapped to different service provider. This can be also useful, and we are going to discuss actually this third part in the second video. So my main device will be MikroTik. I'm going to configure MikroTik in this demonstration, and we are discussing two scenarios. Scenario one, we change the ISP based on the routing table, and when we change the ISP manually, um, all the connected devices are switching immediately to whatever we prefer. And when I say manual, I have one more requirement here. I don't only need to be manual, but I want it to be fast as well. I don't want to go and plug and unplug cables, change configurations, etc. I want to do it with one or two clicks, and I want to have this control of the manual failover. So that would be the idea of this part one. And then in the next video, I'm going to discuss how we can implement this kind of load sharing. So it is it can be used for manual failover, or it can also be used for load sharing because I select my ISP based on the SSID to which I connect. And the beauty of this approach of these scenarios is that they can be used together simultaneously. So it's not one or the other, they can be used together. And in the next minutes, we'll see what is actually in this cloud here in terms of devices, connections, IP addresses, and configurations. So let's get started with scenario one. Change ISP for all devices. So this was my setup initially, and it's pretty straightforward and pretty trivial. So this is my main device with a wireless um, one SSID, which I'm calling now home net. I'm currently connected to it, and this is the internal network. These devices here, the wireless clients, they are getting addresses from the DHCP here, which is giving addresses from the 10.0.1 subnet. All masks are 24 bits, so 255, 255, 255, 0. Then this device is doing NAT to the outside. The Ether 1 is the so-called internet port, the predefined internet port in the MikroTik. What is very important here in this picture is that there is another device, another router, and this router is provided to me by my ISP because I have fiber optic connection on this side and I have a LAN cable on this side. So both of these devices, they are sitting on my table next to me, and this is very important for the simple reason that when we discuss the routing table in a second, we'll discuss that my main default gateway will point to 192.168.1.1. You see these two are from the same network, and this is of course my default gateway. And if ISP1 fails, if I don't have internet connection there, my route is not going to fail. It's still going to be valid because the route will actually check this link here. And this link, this is a 1 meter UTP LAN cable on my desk. It's almost impossible that something goes with this cable when I don't touch it. So this is very important note. So far so good. Then I decided to have a backup ISP. So I wanted to have ISP2. So what I did is I bought a mobile router with a SIM card here, and then I plugged it to port 2. It's not in my room because actually I'm sitting here in my garage and I don't have 3G or 4G, or of course I don't even have uh, uh, I don't make mobile calls here, so I don't have coverage. And I asked my garage neighbors, can I put my 4G mobile data router in your garage, into your place? And we just run a cable between my device and uh, both devices are mine, but we run a cable between my garage and your garage here. This cable is approximately 20 meters long, and we plugged it here in port 2. I said, okay, I'm going to designate Ether 2 as the second internet port, I was not sure exactly what kind of configuration will I want to create, but we did this. Um, in the next moment, they said, okay, but you know that we also have our ISP, which I call ISP3, and they offered me, why don't you use our main ISP, which can be ISP3 from your perspective. I initially said it's not that good idea because actually it's not a big redundancy because ISP1 and ISP3 are the same ISP. It's the same company. It's the same provider. We are just paying different contracts. And most likely, if there is a problem in ISP1, there will be a problem in ISP3 as well, and vice versa. But it's not always the case because we still have these small differences in the what they call it the last mile. So from the provider's perspective, the last mile is um, the connection between their last devices, switches, and other kind of devices to the client home or garage in our case. And we have a difference in the last mile. And furthermore, it already happened once that I didn't have internet. This device was somehow corrupted. Something in the configuration was wrong. Something with the DNS servers. They were starting changing, rebooting, etc. But it was like several hours I was without internet here, but ASP3 was working. So let's say then I agreed and say, okay, let's do it for the sake of the test and for the experiment. It would be cool. But in reality, I don't have like two real backups. I don't have three ISPs. It's less than three, but more than two. Let's say I have two and a half. Then the next question was how to connect. Should we run additional cable here? No. Or they said, okay, we can do one thing, which is we physically split this UTP cable, the 8 wires inside. We can split it in four. So I can have one connection here. We can split it on the other side as well, and use it like this. It's absolutely possible, but I didn't like it. I didn't like it because you have some limitations here. You cannot go more than 100 megabits per second in this case. It will consume, not that it's a problem, but it will consume one more port here. And I said, well, okay, why not we just simply connect your main router to my mobile router. And then the next part would be how we set up the IP addressing. And we simply put all these three interfaces in the same IP subnet. So I started from their router because I didn't want to um, tell them, please change your subnet to whatever. So I just said, okay, what is your default gateway? And they say it's 192.168.0.1. And then I asked them, can you please give me two more addresses from this subnet, which are not used in your network, and they are not part of the DHCP. So I disabled the DHCP here. And then in this group here, you know, when you have a normal home router, you typically have a group of usually 4 ports, which are sharing the same internal IP address, plus the Wi-Fi part as well. So that's why this group here, I'm just using two of these ports. I set up 02 address here, and on Ether2, I set up 010. So they said these two addresses are free and I can use them. And that's actually half of the solution. Maybe you already can imagine what is the next part, and the next part is actually the routing table. And the routing table is just like three default gateways. So what I had before, so if we don't look at this one, if we don't look at this one, and if we forget for a second about this one, normally I had that my clients, they have 10.0.1 and they have 10.0.1.1 as their default gateway, which is going here on the MikroTik. But the MikroTik itself, this is the routing table of the MikroTik. Um, it has to have a routing table as well, and it has to have a default gateway as well. And the default gateway by initially was pointing to 1.1. Now I'm adding two more entries, and one is going to 0.2, which is my ISP2. Another one is going to 0.1, which is my ISP3. And the important thing here is the administrative distance. So this is called administrative distance, and it specifies how preferable the route is. The lower the number, the more preferable the route is. In this case, the route with number 1 is going to be the only one which is used. It doesn't matter if this is the important part here. If my ISP1 fails, it's going to fail here at this part. It's not going to fail here, right? If it fails here, then uh, my router will say, oh, there is no problem with my direct connection, so this route will continue to be active, and these devices will simply lose access. So what I need to do in this case, I need to go inside the MikroTik configuration, maybe right click the route and say disable. When I disable it, it's not going to be used anymore, and the second one in the list is going to be the active default gateway. So when I just go and click disable, ISP2 is going to be my gateway. If I click disable here as well, ISP3 is going to be my default gateway. So I'll change the ISP for all these devices. Then if I go back and click enable, of course, it will turn back to what it was before. Now, what if, I know this can be a question, what if I say one here, and one here, and they are active at the same time? So multiple default gateways, so same destination, 0000/0 means internet, everything. Same destination, three different gateways, same distance. The router will do something which is called equal cost multipath, ECMP, which is basically load balancing. But as I said, I don't want automatic load balancing and automatic failover, because this load balancing is actually you have less control. It is, I think, by default per session. So, for example, from this phone here, you open YouTube video, and then you have one session. It can be bound to ISP1. Then you open Facebook. It's another session. It can be bound to ISP2, etc. And it's load balancing in per session, and I don't want this. And the last approach would be that I still have 111 as a distance, but I keep two of them disabled at any given moment of time. This can also work because in this situation here, only the first route will be used. Then later I go and disable this one and enable the second one, for example, only the second one. The second one will be used. But this can work, but I just want to be sure that if for some reasons all three of them are enabled, all the three routes are enabled, the router will not going to load balance. So that's it, and let's do it now. I have a list of actions that we need to do. So we're going to configure the IP address. It's just configuring something on Ether2, which is this port here. So we have to configure an IP address. We have to configure NAT, so just to make it an internet port. And then we have to add two more entries in the routing table. That's it. And step number 6, which is optional, is a little Python script which I have created, which you can use to just double clicking it, and it will change the service provider that you want to use. So let's do it, and I will start by connecting to using Winbox 10011, and then I'm going to connect to my device. So first of all, let's see what do we have. Interfaces. This is my 5 gigahertz network. This is my 2.4, which I have disabled for now, and this is my home net. Home net. So in terms of IP addresses, I have 10.0.1.1, which is connected, which is assigned to the bridge. Let's go here and see the picture again. So the bridge is the default internal, let's call it interface, which combines all the ports except port 1, ether 1, which is for internet. It's another port separate. Um, and this interface bridge has the 10.0.1.1, which is the default gateway for the clients. So if I type ipconfig now, I'll see 10.0.1.100 is my address now, and 10.0.1.1 is my default gateway. This is my default gateway. On the other side, I have 192.168.8.2, and if you paid attention, it's a dynamic address. It's coming dynamically from this device. And 1.1 is actually my default gateway. I can see it here. By the way, I don't care if it's dynamic or static. I don't care if this router tomorrow gives me 1.3, for example, or 1. Something else. I'm still going to use the same default gateway. And I have this route manually created here. IP routes. You see, this is my only default gateway going to ISP1. So let's start with this part of the configuration. First of all, exclude ether2 from bridge and give it an IP address. Again, just to configure ether2 as internet port, I have to exclude it from this group, which is called bridge, and then it will be alone. It will be just a separate port, which I'm going to use for uh, internet 2, another internet port. So what I need to do, go to bridge here, and you see that all these interfaces, so ether 2, 3, 4, 5, and the two wireless interfaces are in the bridge, which is called bridge. So what one is not here. And what I want to do is to exclude ether2 from here as well. That's it. And then I'm going to assign it an IP address. So I'll go here, here, and say another IP address, which should be 192.168.0.10/24. I'm going to assign this IP address to ether2. And that's it. So I can say now that the first point is done. Create NAT path, which is called masquerade in MikroTik for the traffic exiting out of port ether2. So network address translation, which is actually port address translation, which is actually called masquerade in MikroTik for all the traffic which is going to ether2. And this will actually make the port as an internet port. Basically, this is these are the minimum steps that we have to do. So IP firewall, in the NAT section here, I already have one masquerade rule, which is the source NAT that we need, and this is for ether1. And ether1 is the default internet port. It's not saying here ether1, it's saying out interface list, because there is a additional configuration, default configuration, which says ether1 is in the interface list, which is called 1 or WAN. I don't touch this rule. I create another one. In the general, I simply say So I don't touch it. It's in the source, not chain. Nothing here. What I'm interested here is the outbound interface. And the outbound interface is Ether2. My traffic is going to exit out of Ether2. And the action should be masquerade, which is again not path configuration. That's it. Again, these two rules are very similar. The only difference is that here Ether1 is in a, let's say it's like a group, another group, but I don't want to touch this configuration. I just put this individual port into outbound interface of my NAT. So what I have here is this is created as well. Let's then create the routes, and that would be it for this part. IP routes, I have one default gateway. I'm going to create the second one, which will be 192.168.0.2. Very important, the distance is going to be 2. And that's it. So it's not, it doesn't look like working now because it is in red. So something is not quite correct. So let's see what is it. It says invalid, unreachable, static, and hardware offloaded. So let's see what's going on here. 192.168.0.2. So the IP address here of the default gateway looks correct. And let's see what I have done wrong when I go back to IP addresses. Oh, here it is. I've configured the wrong IP address. So it's 192.168.0.10. And then if I go back to IP routes, it should be not in red, but it is in blue. What does this mean? It means that it's not active. It's not used. It's actually not in the um, not in usage of the MikroTik right now. It's not in usage because I have another one which is with administrative distance lower than this one. So in this, let's mark this as done. Another thing is done here. This one is done, and then I'll switch and immediately create another one just to I want to make more checkboxes as done. The third gateway 192.168 is 0.1, and the distance here is 3. So another one in blue which is not used at the moment, and another checkbox here. And that's it. To change the ISP for all devices, just disable the default gateway routes which you don't want to use. The active one with the lowest metric will become your ISP. So let's see what is my current ISP. So two ways to check. One is to do a trace route. So I'm going to do trace route minus D. Minus D is not um, to do the opposite DNS request from IP to a host name. And this will just be faster. And I'll do it to 8888. Then I'll stop it after step number 2, which is pointing 1.1, and 1.1 again is my ISP.1. If I now open a browser and go to one of these, what is my IP addresses, I think the fastest one I know is ping EU. You see that my public IP address ends on 125.92. So far so good. And let's change it. Let's see if our configuration works. So what I need to do is I click on the only thing I need to do is I click on the route and click disable. Then maybe refresh it somehow. F5. Okay, it works. And you see this one looks the only active, and this is my ISP2. And again, two ways to check it. I repeat the trace route, stop it after the second step, which is important. And you see previously it was 1.1, now it is 2.0. And 2.0 is actually my second ISP. And if I go and refresh to see my public IP, it ends on 59.39. It's totally different IP address. And then, of course, we'll disable this one as well and do a refresh. So this one looks active. Let's immediately check the routing table. Not the routing table, but the trace route. So 01. So 110201. And then my public IP address, it's 91.152. So it's the third IP address. So let's enable back those routes, and I'm going to go here and click number 5. And finally, I want to somehow a little bit automate this. And I have already created um, 3 little scripts which are on my desktop in a folder which is called MikroTik scripts. And these are Python scripts. And what they have is actually very, very simple, but you have to do some prerequisites before doing. If you want to do something similar. So I'll open this with Visual Studio Code, which I will use for editor, and I'll quickly explain what I have done. So first thing, you need Python. You need to install Python on your computer, and then you need to install a library which is called netmiko. So netmiko is a popular library which um, simplifies the connection to different networking devices and the execution of some commands remotely. So netmiko supports different devices, including MikroTik. And the connection which I'm doing with this script to my MikroTik is via SSH. So you need to install Python first step. You need to install netmiko as step number 2. There are different tutorials which you can have a look to see how you can do this. And then I'm importing um, from netmiko one function which is called connect handler, which I'm going to use later in order to connect to my device. And I'm importing one function which is, let's say, built in Python, getPass, because I don't want to put my password in a clear text in this configuration. So that's it. The first step here is that my script is prompting me for a password. So it says, give me your password. That's the first thing. And this is the password for what? This is the password for uh, SSHing to this IP address with this username. So the username can also be set in a variable, but in my case, it's just admin. And we just put the password here in order to create this variable, which I call it empty, maybe from MikroTik. And that's it. And then I create another variable, netConnect, which is using the connect handler function, which we previously imported, with the details about my MikroTik device, the IP address, the username, and the password. And that's actually the little dirty part before the actual work. And the actual work are just these 3 commands. And these 3 commands are doing enable for one route and disable for the other 2 routes. And how are they matching the exact route? By finding the comment or the description of the route. So if I want my script, or actually these are 3 scripts, one for ISP1, for ISP2 separate one, for ISP3 separate one. This is the easiest way. And if I want to make it work, because at the moment it will not work, is I just need to fix the descriptions of my connections. So you see how I'm calling them. To ISP1 is the first route, which I think is already done, to ISP2 and to ISP3. So let's do it. You see, to ISP1 is the description. If you go or comment, this is already done. Then 02 is ISP2. I can either click it and say comment here, or I simply go to this button here, which is comment, and I say to ISP2. This is how I will match it so my script will can work. Of course, there are so many different ways to do it, but I find this the simplest way and very effective. So the last one, which I call it to ISP3. And let me show you one more time the other scripts which are very similar. And by the way, I'm doing right click open with because I have associated the py or Python extension uh, when you I just want when I double click on the file to be executed by Python, and that's why I do right click open with. So this is the second one, and it's completely the same until this point here. You see, now I'm just enabling the second root and disabling the other two. And the other what is different is the display message which says, oh, congratulations, now you are using ISP2. And it's similar for ISP3. For ISP3, this one is enabled and the other two are disabled. And then I print this message to the user who is executing the script and waiting for enter. Otherwise, it will disappear and will not see the output. And by the way, if there are some errors, for example, the IP address is not reachable or the password is wrong, etc., you are not going to see this message. So if you see this message, this means that the script was executed successfully. So let's start and see how it works. Let's see F5 here. The active route is to ISP1, obviously, and then I'm going to double click this one, which is saying ISP2. It opens another window, and the only thing I need to do is put my password, hit enter, and now it says using root to ISP2 now. Maybe hit F5 here and see this one is active. Let's hit enter and see if it's actually ISP2. Trace route, and second step is going to 02. Just to see the picture again, 02 is ISP2. So far so good. Let's see the other one. Double click this one, and then I have this window here. Give me your password. Here is the password using the root to ISP3 now, and you can see here it's automatically enabling one and disabling the other two. Although, as we discussed previously, if I, for example, execute the ISP1 script, there is not always the need to disable the other two. If the three are enabled, it will only be used the first one. But just to be, I don't know, you can make it one way or the other. So let's check if I'm using now ISP 3. It should go out via 01, and that's it. So finally, I will switch back to ISP1. So entering my password and see what happened here. 2 ISP1 is the only active one. So that was it. I hope it was useful, but in part 2, we are going to discuss, for me, even more interesting scenario. And we are going to use different ISP per SSID or per wireless network. So see you in the next video. Thank you. Bye bye.